Hiya folks, this is Kellen here. I've decided to make a series of videos on the C programming language. So as my source material, I'm using the classic second edition of the C programming language by Brian Kernighan and Dennis Ritchie. Before we get started, there's like a concept I'd like to teach you, and that is the concept of compilation. So you've got the source file on the left, which is a file that contains a bunch of C code. You feed it into a compiler, which reads that C code and turns it into a binary. And a binary is the thing that actually executes on your computer. It's constituted of a bunch of machine instructions. So C is a compiled language, not an interpreted language, which means that you have to compile your source code into an executable. And the thing is, the compiler is the ultimate authority on the language. So if you define some stuff in your source file that the compiler doesn't understand, the compiler is going to yell at you, and we'll see that happen as we progress here. So I've opened up a command prompt here, and I'm using Windows. What I'm doing is checking that I have the C compiler installed, so gcc-s version, and I do have a C compiler installed. There's a lot of different ways to get a C compiler installed, and you'll have to look up how to do that yourself. There's instructions out there on the web that you can follow. So we have a C compiler installed, so the first thing to do is to write some C code. So you're going to type exactly what I'm typing here. Include standardIO.h. And print f hello, comma, world. So we're going to save that file, and we'll call it hello world. Let's try again. Okay, so now that that file's saved, we can do a bit of command line trickery here. If you type dir in command prompt, at least, it'll list all the contents of a directory. So as you can see, we have our hello world.c file. Now we're going to invoke the compiler, the GNU compiler connection, or the GNU C compiler -o hello world.exe. That's the name of the binary we want to have produced. And then here's the input into the compiler. It's a C file, right? So let's do that. Okay, it looked like it compiled. If you don't get any output from the GCC command, that means everything went smoothly. Okay, now let's run the hello world program by just invoking it by its name. And there we go. We got the words hello world printed out. So we've written our first C program, and this is probably going to generate a lot of questions for you because this syntax is unfamiliar, right? What is include standardIO.h? What's main? What's printf? What's the quotes? What do they mean, right? What does all this mean? Well, I'll attempt to explain each part of this program in pieces. So, here we go. We're in Paint right now. Okay, so here's our program on the left, right? It's include standardIO.h main right? So the first line, include, it just says include information about standard library. So To get functionality out of your program, you usually use a library, a standard library. So things in the standard library might be functions for input and output, reading files, comparing strings, yada, yada, yada. That's not going to make a whole lot of sense to you right now, but just know that in our programs going forward, we're going to have this include line. Okay, main. Main is a function, and we'll get into what functions really are later on in the series. So just know that any program starts executing from main. So all programs need a point at which they start execution. Main is that point. The statements of main are enclosed in braces, so these open curly brace and this closed curly brace define the body of the main function. And inside the main function, we have a statement here, a printf statement. It says, main calls library function printf to print the sequence of characters. \n represents the new line character. Okay, so if we want to print to the console or to the command prompt, we simply pass in hello world or whatever text we want to print, right? In this case, it's hello world. So that's, sort of picking apart our first program piece by piece. And don't be afraid if this explanation doesn't really make any sense right now. It's a small program, but there's still a lot that has to go on in order for a simple program to work. So there's some pieces to it, right? And we're going to explore these pieces in more depth as we go on. Okay, so printing hello world is pretty boring. We could spice things up a bit by maybe printing something different like so let's save that. And if we run hello world again, notice that because the binary hasn't been recompiled, it's still printing hello world, right? So we need to, anytime you make a source code change, you need to recompile the source code to produce an executable. So we'll do that. This is the recompilation step. It's a two-step process, right? Make your change in the source, recompile. Okay, it compiled. Let's run it. And there we go. We get the new text. So let's explain a little bit here. When you use double quotes in C, you are denoting a character string. Sometimes it's called a string literal. Sometimes we refer to this data just by the name string, right? This is a string. Anything between double quotes is a string. A string is simply a sequence of characters. This string happens to begin with the character uppercase W. And then there's a special character, this \n, called an escape sequence. And that advances output to the next line. So if I show you, right now, if we look at the output of our program, right, there's a blank line after we invoke it. So what if we got rid of that \n, saved, right, recompiled, ran. Notice we didn't get a new line now. Okay, so that's a worthy experiment, right? So I would encourage you to experiment with making your own custom string and omitting the escape sequence for a new line. Okay, so I'm going to purposely cause some compile errors here just so you get some exposure to what that's like, right? What if I get rid of this include standard IO line? Let's try to save. Let's recompile. Now notice the compiler is giving us a warning. Implicit declaration of function printf. And here's a note it gave us. It says include standard io.h or provide a declaration, right? Now notice these are warnings. Let's delete hello world.exe. So, and let's see. These are only warnings, which means that the compiler is detecting that something is going wrong, but it still produced an executable for us. We can run it now. Right, it's still producing output. But really, we should try to clean up these warnings if we see them, right? Because there could be things that the compiler warns us about that could be important for the execution of the program. So those are warnings, right? They don't prevent your program from compiling, but the compiler does take note of them and warn you of, stuff. Okay, let's cause an error. Let's omit the ending parentheses of main. So let's save that. Let's try to compile it. Notice now we get an error. It's even highlighting the error text in red for us. It says expected declaration specifiers ... before curly brace. So on line 2, there's something going wrong here, right? So let's go to line 2. Well, we're missing a ending parentheses. Every function call, when you declare a function, it needs at least an open and close parentheses. So let's fix that. And let's also fix the warning by including standard io.h. So if we recompile, we get no warnings or errors, so we have an executable. So our program is running the right way now. Let's try another thing. Let's omit, let's just say this is some junk. So let's save this, compile it. It says missing terminating quote character, expected expression before the ending curly brace, expected a semicolon before the ending curly brace. So error messages, to be honest, are a little bit cryptic, but it says what line it occurred on and what column it occurred on. So if we go to line 5 of our source file, line 5 is here, and column 16, there we go. The error is occurring somewhere on this line, right? And we can figure out, we can intuit that, oh, I forgot an ending quote to my string. So let's add that ending quote. Let's recompile, rerun, and it produced some output. So I would encourage you to do a bunch of experimentations where you just start leaving out different parts of your program and see what kind of compiler errors you get. Compiler errors are going to be pretty common when you first start coding, and it's going to be frustrating, I'll be honest, because a compile error means that the program was not produced. And so you won't even be able to run the program that you want to if it has compiler errors. Another thing that we might do is we might, instead of printing a string in one shot, we might break it up, right? So we might say printf this is some junk. Now I'm using multiple printf statements. And this is being sequentially executed by the computer. It's reading this line, producing this, goes on to this line, is, goes on to this line, some, goes on to this line, junk. So in our final output, we'll see this is some junk, all appearing on one line. So if you have a really long string that you want to produce to the console, you might break it up by using multiple printf statements. Okay, so the last thing I'm going to teach you in this introductory video is how to insert quotes into an already quoted string, right? So we might want to put quotes around the word junk in our output. How would we do that? Well, if we just naively do this, and then the compiler is going to yell at us, right? It says on line 8 there's some issue going on. The issue is we haven't escaped the quotes. So let's go back. If you precede a quote with a backslash, that escapes the quote, which means it will appear in the output of the program. So now if we recompile and run, we see this is some junk with quotes around it. Okay, that's the last thing I'm going to teach you in this first video. I hope I haven't confused you too much. As you spend more time looking at code and working with it, you'll become better. It just takes time and patience. So exercise some patience with yourself. If you're completely new to computer programming, starting off with C might be a bit rough. So just expect yourself to maybe not learn as quickly as you'd like. But that's okay. Everybody learns at their own pace, right? Okay, bye.